So now that we've talked a bit about reactive programming from a conceptual point of view, we talked about the Flow API, I talked a bit about the different frameworks that implement that API, RxJava, Project Reactor. We talked a little bit about how the reactive programming principles map onto the various features that you'd find in these modern reactive streams frameworks. Let's now start a deeper dive into key classes in Project Reactor. And that's what we're going to be focusing on in this course, is Project Reactor. And the reason for that is it's newer, it's cooler, and most importantly, it integrates nicely with Flux, which is a reactive web programming environment. So the two classes we're going to take a deeper look at here are called Mono and called Flux. And of course, the pun here is Flux Reactor. So anybody here who's a physicist knows there's something called a flux reactor. So that was the joke that they did, the inside joke. So Mono is the simpler of the two classes in the Project Reactor API. And as I had outlined earlier, it completes successfully or with failure and may or may not emit a single value. Obviously, if it succeeds, it'll emit a value. If it doesn't succeed, it won't emit a value. And you can read more about the Mono class here at this link. It's very similar to a Java completable future or to an asynchronous optional. And we're going to take a closer look at this example when we get to the case studies sections later. But in a nutshell, what's happening here is we're using a factory method called fromCallable to take a supplier lambda, which is going to reduce an unreduced big fraction. So it's going to convert that into a reduced big fraction. And then we're going to use subscribe on, which is a concurrency operator, which says run this entire computation in a single background thread asynchronously. And then we're going to use map, which is a transforming operator, to take the reduced big fraction and convert it to a mixed string. And then finally, we're going to use the do on success action operator in order to be able to essentially print the results out. Now, this particular piece of code actually is not going to do anything because it doesn't have a subscribe operator on it, but you'll see when we talk about the actual example how it's all going to work to do something more interesting. So again, very much like streams in a sense, or very much like computable futures, we start an operation that's going to run in the background, and then we're going to go ahead and subscribe, and that'll then tell it to run in a background thread, and then we do some transformations and other operations on these things. Okay. Mono operators and mono behaviors are documented by something that's called a marble diagram, which is kind of a funny name. And you can read more about marble diagrams here at this link, if you're so inclined. The timeline of a mono is read from left to right. So this is the beginning and this is the end. And this little circle, green circle, is the optional item that's emitted by the mono. So it's going to emit an optional item. The dotted lines here and this box indicate the transformation that's being applied, what is being done to this particular element. And the text inside the box indicates the specific operator that's being defined or applied. This mono is the result of the transformation, and if it succeeds, then you end up here after the item is emitted, and if you fail, then you'll have a failure. You will not emit an item. There's a lot of operators that are defined as part of monos. There's factory methods that convert typically non-reactive things into reactive things. There's transforming operators like map that make some conversion. There's action operators that have side effects. There's concurrency and scheduler operators that will be used to run things in the appropriate threads. There's combining operators that work like some of the completion stage methods in completable futures to take one or more results or two or more results and combine them together in various ways. There's suppressing operators that will ignore the payload for various purposes. There's blocking operators that cause asynchronous operations to halt and wait until something is finished, et cetera, et cetera, et cetera. There's a lot of these operators. Basically, there's even more operators in reactive streams than there are in the streams framework, the operations in the streams framework. There's just gaggles of them. The next kind of class we're going to talk about is the Flux. And this is the one that can emit an indefinite number of events, either 0 to infinite, and may or may not complete successfully. It could fail, it could succeed. It all depends. And it's very similar to an asynchronous Java stream. It's kind of like combining completable futures with a Java stream, except it's a little bit better thought out than that combination because they really weren't completely designed to work together, although they do work together nicely. So here's a very simple example of a Flux, which is going to have a create factory method that will emit a bunch of big fractions up to a certain limit indicated by take. It will then use the flat map operator, which does some really cool things to do a bunch of operations concurrently. It collects all those concurrent operations into a list, and then it goes ahead and sorts and prints the results. So we'll walk through all this stuff, of course, and I'll explain what everything means. But that's basically the way that the flow works with a Flux. A Flux supports back pressure, which means that the subscriber can indicate to the publisher how much data it can consume before it requires the publisher to stop and wait for the subscriber to tell it to send the next chunk of data. You can also document fluxes with marble diagrams, just like you can document the monos. Once again, we have this timeline where things flow from left to right. These are the items that are emitted by the Flux. The dotted line in the box indicates that transformation is being applied. The text inside the box indicates a particular type of transformation like map or flat map or due on success and so on. These elements are the results of the transformation. If it all goes well, you'll have a vertical line at the end that says we successfully completed our transformation. And if something goes wrong, then we're going to end up getting this vertical line replaced by an X, just to indicate what happens when errors occur. As with monos, there are lots and lots and lots of operators. They're basically the same operators as there are for monos. The difference being, of course, that a Flux generates a stream of these things, whereas a mono will only generate at most one. So that's the main difference. Okay, so that's a quick overview of the key classes. Obviously, at this point, you would probably not be in a position to program anything with fluxes and monos, so we will get into those in more detail as we go a little further along.